It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to another episode of Pure Performance. My name is Brian Wilson, and as always, my wonderful host, Andy Grabner, is here. I hope. Andy, are you here?
Well, where else would I be? We're still locked up at home in this pandemic, right?
I don't know. I thought you might be out somewhere learning how to do your own separate audio recording this year by yourself and keeping it secret from me this whole time.
Really? I know you just learned something new, but actually I have the power of recording stuff locally. I'm sorry that I never told you, but I guess you never really asked, or maybe I just ignored it when you asked years ago.
Yes. So I'll just get this part of the way because I like to shame. Sorry about the audio quality this week, folks. We've been having more and more problems with Ringer. So Ringer, if you're listening, let this be fair warning. But yeah, we're backing up to a Zoom recording, which gives us pretty low resolution. So hopefully it's not too bad. Hopefully everyone will continue listening because we have quite a wonderful show today. Andy, why don't you introduce the show topic and then our wonderful guest?
Definitely. Well, I think, if the quality of the sound is not that good, we just make up for it with the quality of the content, right? That's the way we do it here.
Yeah.
All right. So today I was actually introduced to our guest today through his podcast, Kubelist. And I just had an episode recording around Captain, and the guest, therefore, is the person who runs the Kubelist podcast. I'm pretty sure he can tell us much more than I can about himself, about the podcast, and about his background. And this is why I want to introduce Marc Campbell, founder and CTO at Replicated.com, and probably doing a lot of other things that we don't know about. But Marc, welcome to the show, and let the audience know who you are and what you're doing.
Great. Yeah. Thanks for having me. Andy and Brian, it's great to be here. Andy, so my name is Marc. I'm the CTO and co-founder of a company called Replicated. We've been around for about 5.5 years, basically helping SaaS companies and software companies ship their software to their largest enterprise customers behind the firewall. So we work with companies like Puppet and HashiCorp and Circle CI. And they take the software that they're running in a SaaS product and package it up for Kubernetes, ship it behind the firewall so their customers can run it.
Mm-hmm. So that's obviously, extremely interesting for, first of all, us, Dynatrace. Brian and I, we work for Dynatrace, and we have the same deployment model, right? We have a SaaS solution, but we ship it to many of our customers also on-premise. We call it the Dynatrace managed offering. We are shipping it through our means that we've built over the years. But I clearly see that obviously this is a very important deployment model because unfortunately not everybody can always use software as a SaaS offering. Now, Marc, before we go into the topic, because we asked you to come on the show and really talk about, first of all, I want to just get some additional background on why people are deciding to do this, to move from SaaS to on-premise, even though I think it's clear, but still just some intro for people that had never thought about that. And then the other thing is we really want to talk about what are challenges when running software on-premise that, you obviously work, how it runs well in the SaaS environment that you've developed it for. But can you, before we dive into this topic, how often do you see that organizations, become very successful with SaaS and then realize, oh my gosh, how can I do this now on premise? Because all of a sudden I get a demand. So is this the common use case, or do people from the start, when they think about building SaaS, already think about SaaS and on-premise? What's the most common use case here, or the most common thought?
Yeah, that's a great question. So, when we started Replicated, we thought the primary use case was going to be an existing SaaS product, met a large sales opportunity and that opportunity required them to ship it on-prem behind the firewall. And just to clarify, like when I say on-prem, it doesn't often mean like bare metal server sitting in a server closet somewhere. It's like it's the customer's AWS account or the customer's Azure account these days. But yeah, we thought that was the primary use case, and that is a big use case. But there's also a lot of traditional on-prem software that's being rewritten to be microservice Kubernetes based, and the deployment model that they've been running with for years has been to ship a jar or a WAR file to their customer, let them spin up a database, and then run it in Tomcat or whatever the web server is that they choose. And now the developers have chosen Kubernetes to write the software because it's like they get a lot of benefits from this platform, and that just increased the complexity of that deployment to those customers. And so they need a way to help solve some of that. So it's like, yeah, like a lot of it is SaaS that is growing from a startup into like more enterprise sales, but it's also just the proliferation of Kubernetes has created this challenge too.
That's actually interesting. So if I understand this correctly, traditional software has been containerized and maybe put into Kubernetes because obviously, right, that's the way to go. And but then people realizing instead of running it on premise, pushing the complexity of Kubernetes to the customers, then why not just take it and then also provide it as SaaS? So I think that's interesting that obviously these two models or these two directions come up, because initially I guess just as you, I would have thought that somebody comes up with a great new idea, obviously builds things containerized, run it somewhere in a Kubernetes probably managed offering in the cloud or a SaaS offering, and then kind of being challenged with, well, how can we now not only run this, but I think the biggest challenge is really how do we distribute it also behind the firewall, right? Because that's probably a big challenge too, because if we have these air-gapped systems, you cannot just upload it to Docker Hub or somewhere else and then people download it from there.
Yeah, exactly. I mean, we look at the problem as there's really two problems to solve when running software behind the firewall. Day one and day two operation problems. And day one is just how are you going to get it installed and provide all the functionality that you need to there around licensing and entitlements. Like how are you going to make sure the enterprise is paying you for the software, like they're successfully getting it running in their environment. But then down the road, how are they going to operate it? 6 months from now, it's not performing well, or it's crashing, or they need to, upgrade it. The shape of their enterprise has changed a little bit, and their usage patterns have, and it's in an air-gapped, totally sealed off environment. And you, as the ISV, how are you going to understand that and be able to help them troubleshoot it? Because they don't have that operational expertise in like the database components, the queue components, all of the various technical components that you're shipping with your application.
Now, that's an interesting question. So if you think about a completely air-gapped system and something happens, do you have any kind of quote unquote best practices, or are there any frameworks, any other tools out there that provide, I don't know, some support for, I don't know, collecting the right log files, collecting monitoring data, collecting whatever needs to be collected, environment information, so that this information can then be somehow shipped over or sent over to the ISV to then have a look at it? Are there any standards maybe even, or is there any type of tooling around that has been kind of become a de facto standard for that, or how does that work?
Yeah. So Kubernetes definitely makes it easier, right? Before Kubernetes, you would have had to know the location of log files and know what specifically to look for, collect it all, and send it back. And with Kubernetes, at least now we can, run kubectl logs and kubectl describe pod, and whatever it is that you want to run, you can generally access them all through a common CLI now. But as part of that's a lot of the functionality that Replicated actually does provide. And we actually released an open source tool just called Troubleshoot. And it is a way to declaratively in a YAML file describe what you want to collect, and then provide automatic redaction. Because, generally, if you're going to collect log files and pod,
contains sensitive information and things like that.
Yeah. Exactly. There's passwords. There's PII, and so it redacts it all. And like this is just a total open source like component called Replicated Troubleshoot. It's not. You can use it without even talking to us, signing up. It's not tied to any service that we have. It allows you just to like collect all that, and it eliminates the slow asynchronous kind of like back and forth troubleshooting that you otherwise would have had to do. Because if you have a customer who's having a problem and you need to collect logs, you'll just say, great, like, can you give me the logs of this pod or this, like follow this deployment pod like log for a little while and grab them. And then that may just say, great, now I actually need to go describe this service to see, how it's configured. And, that asynchronous process just becomes tedious in those air-gapped environments. And so collecting it all at once, getting it all into a giant tar gzip, support bundle type thing is super useful.
Yeah, I mean, Brian, this reminds me a lot what we are obviously doing, right, with Dynatrace. Even back in the AppMon days when we said, get a support, we call it a support archive, which was basically a way to collect all sorts of logs and config files that were relevant for us to understand what the environment looks like and where the problem might be, and then ship it or send it to our support team. Archie, exactly.
Archie, right?
Yeah, Archie. So, Mark, that might be a strange name.
Good thing to hear about, actually, because it could come in handy.
Yeah, so maybe this is something for you too to think about. So we had we collect something that we call a support archive, right? Like, as you said, collecting all the logs and config and then zipping it up, and then when it was uploaded to, we were using Jira for support tickets, and if they were uploaded, then the engineers typically unzip it and then they look for patterns. And so our engineering team said, you know what, we can automate that. So they developed a tool that they called Archie, for archive analyzer, basically. And that Archie was triggered every time somebody uploaded one of these support archives to Jira. And then our developers could actually also write some rules that were automatically parsing or scanning for certain log patterns and for certain things that they already knew. And so it automated a lot of the initial troubleshooting steps.
Yeah, that's exactly what the troubleshoot product tries to do too.
Cool.
we talked about the collection. You can write a custom resource, which is a kind, collector or whatever, and that defines everything to collect. And then, you can also write these analyzers, and like, to your point, the automation of that is great when you can say, it is running on this version of Kubernetes and it has this ingress controller and this shows up in a log. Here's a link to a support article. And what we try to think about is really when a third party is running that piece of software, how can we push that like self-service and that remediation capabilities all the way down into their cluster, into their hands, so that they're not, if Dynatrace were to ship software behind the firewall like that, you don't want your customers to be completely dependent and relying on you and your support team every time something goes wrong. You want to give them the function, the tools, especially if they're Kubernetes experts, to be able to, understand how to troubleshoot the system and get it back up.
Yeah.
Really cool. Now, let me ask you a question. So we talk about Kubernetes here, right? And I mean, when I started my journey with Kubernetes about 2 years ago, I was under the impression that every Kubernetes was made equal. And if I run my pods somewhere, then I can run it anywhere. But obviously, well, this is not the case, because otherwise we wouldn't have this conversation probably. So why is it still, after so many years of Kubernetes development and obviously the product or the platform and all the community and the ecosystem around it, obviously investing a lot in I think in standards and then making the product more solid or the platform more solid, why is it still the case that we don't have a situation where I can run my application anywhere, regardless of whether this is in Azure or in AWS or wherever I run it?
Yeah, I mean, I ask that all the time too. Like, it's a good question. I think, Kubernetes is that abstraction and that common API, and the way that we look at it is like the real value of Kubernetes is all of this complexity that you had in your application around deployments, around rolling updates, around networking and storage. It's pushed that complexity down into this platform. So you don't have to think about it at the application layer anymore. The platform is now responsible for it. But there's little variations on that platform, and you start to realize it when you go into unknown or potentially even hostile style Kubernetes environments. Like you might be used to running on GKE or EKS that has like an EBS PVC provisioner and everything's working great. You have EFS behind it. And some classic examples here that we run into is your application may expect to be able to provision or read write many PVC in Kubernetes, and not all Kubernetes clusters make that guarantee that you can do that. And so that doesn't work. You might expect that there's an ingress controller, that you can have a load balancer type because the cloud provider you're deploying to supports that, and that's not true all the time. Disk IO, network IO is like super dependent, and like at scale and at load, Kubernetes really relies on that etcd behind it to perform. And on an under provisioned server, and like in different cloud providers, just the disk IO performance is going to be a little bit different and unpredictable, which like you talk about this a lot on the podcast here on other episodes, where like that just propagates up into like unexpected types of failures, and you have to understand how to run those. Just the cloud providers are all different, and then on a totally different layer, there's just like flavors of Kubernetes that you need to think about. OpenShift being a big one, right? You might be totally your app runs great in Kubernetes, you met all the requirements and everything, but you have decided that like when you're running it in your Kubernetes cluster, you understand the risks, and like you're managing that, but it's okay to run as root in this one pod. But like as soon as you deploy it to a customer and they're in a sensitive, like regulated industry, and they don't want anything running as root, they're running it as OpenShift, and it's just going to fail to run at that point.
Yeah, actually, it's funny that you mentioned this example, because just got off the call earlier, and we had one of our users of the open source project, Captain, that we are building. They had the same thing with their OpenShift environment, right? Some of our containers that require root access were not able to run. So we work with them and also with Red Hat to make this work. But that makes a lot of sense.
And Andy, I have to say, I love the idea of a hostile Kubernetes deployment. Yeah. It makes me think of, if you're familiar with the Hitchhiker's Guide books, Marvin, the paranoid android, you could have Oscar the grouchy Kubernetes cluster. Every time you type in a kube control, come on, what do you want? Just seeing a personified Kubernetes cluster, that would be really awesome. If your YAML is wrong. Sorry, I just got hung up on that idea. I had to bring it up.
So, but Mark, if that is the case, then I wonder what have we gained from all of Kubernetes? Because in the end, if I think back of the days prior to Kubernetes, when we wrote software, we were basically saying, what are the system requirements? We said this particular version of Windows or Linux, and these hardware requirements are supported because they're also tested. So does this mean in the Kubernetes world, actually nothing has changed, that we still have to say our software requires exactly these hardware combinations and software combinations because this is what we've tested for? Or is at least that's what it sounds to me.
No, I mean, I think that's fair. I don't think that that's true. I think, my message is more like it's continuing to evolve. We've made huge strides with Kubernetes, and you don't have to rely on that anymore. An example that I like to talk about here is, traditionally, SAP HANA is a piece of on-prem software that enterprises may be familiar with. And to deploy SAP HANA, it literally was a 95-page manual that you needed to get it running. And you would have to put a team of 6-10 engineers together and spend, a year provisioning hardware and getting that all up and running. And it's just not that. Kubernetes has definitely solved that problem. And its day one operations are really easy. We have a tool for it, Helm. Kubernetes operators work. It's really easy. I think my message is really around that long tail of expectations. If you are shipping into similar Kubernetes environments, then similar now is a lot bigger than it ever used to be. Kubernetes has kind of leveled that field a lot. There is still this long tail that you have to be aware of around little differences, and just go into it with eyes wide open when you're shipping to the behind the firewall, and understand how are you going to troubleshoot that, and how are you going to think about performance and load testing and chaos, being prepared for like understanding what these problems are going to be. Like, but like Kubernetes has definitely normalized that, both in like a technical perspective and really in like a people and an operations perspective. Before, if you shipped software as a jar file, the example I gave earlier, you kind of expected that, maybe your customer had a little bit of expertise with, Java runtime and Java, being able to like get the JRE running, or you had Elasticsearch as a requirement and they would have to configure Elasticsearch. And now it's just Kubernetes deployments and Kubernetes config maps and Kubernetes secrets. And so you can rely on this level of common, expertise, and they can run a Kubernetes cluster for you. And it's not just running a Linux server that you're just going to be super unfamiliar with, like the distribution of Linux and the kernel that's on it.
Yeah, no, I get your point. I think that's fair. Obviously, we get this additional level of abstraction that at least levels it takes away the unknown things underneath the Kubernetes platform. So the platform itself should be kind of at least standard. But still, let me ask you a question. In your experience with the people you work with, how often do you see that the software that is then getting deployed on-premise runs on existing Kubernetes platforms or Kubernetes clusters that the customer already provides, and where they maybe have some other software running? Or how often does it happen, and maybe it should happen, that you say, well, I need a dedicated Kubernetes cluster in order for us to perform as expected?
Yeah, I mean, so we solve for both of those problems. Our goal is really to let you as an ISV ship your Kubernetes application and target either of those customers at either end of that spectrum, zero Kubernetes expertise to, like a super modern enterprise who has a great Kubernetes story, they're running it in production or anywhere along the way. But to answer the question, I think, today, I think there's still a lot of enterprises that choose to kind of treat a Kubernetes application as an appliance. And it might be like, 60-40 or 70-30, where the larger number is the folks who are just coming with some Linux boxes and they want to run, a curl pipe bash command, or they want to spin up an AMI. And the fact that it's Kubernetes underneath that doesn't mean anything to them. It just happens to be that way. But we're definitely building for this future that we're seeing, in like the Kubernetes adoption is crazy. It's growing so fast right now, and we're building towards this world where that's going to be the minority and eventually gone. Like every enterprise is going to have Kubernetes and have operational expertise in Kubernetes. And if you're running on Azure, if you're a large bank and you decide, hey, we're going to run everything on Azure, it's pretty easy just to spin up an AKS cluster and deploy an application to it. You don't need these snowflakes and special environments. It just helps you be able to manage it more. I think it's pretty quick. Every month that goes by right now, more and more enterprises have Kubernetes that they're willing to deploy to.
Mm-hmm. Now let me ask you another question. So we have I've in the last 2 years worked a lot with Kubernetes, especially in our open source project Captain, and have installed it or tried to help people install it in their environments. And we very often ran into things you mentioned earlier, either special restrictions in their environment. Typically, we run into some network issues. Sometimes we run into storage issues, but or like these air-gapped systems where they're not allowed to download anything. So you download it somehow. You get them to download the containers, put them into their registry through the security scans, and then eventually, you step by step, you actually find out which containers and you actually need to run it, and then also what you're all depending on. But is there a list or a good guide for developers or organizations that are building software now that they want to run on premise later on, like a checklist saying, hey, so here are the things you should know and you should test for? You mentioned chaos engineering earlier. Are there maybe some environments or some environment combinations that everyone should test for to really make sure that they at least have 80 to 90% of common problems kind of ruled out before they start deploying on premise?
Yeah. I mean, So I think generally, if you're building as vanilla Kubernetes as possible, it's going to work. And you have to really think about security also. If you're deploying a Kubernetes application, but you're going to rely on a dozen CRDs or operators, that's just going to require cluster admin level RBAC permissions to do that installation, and it may cause some challenges. So definitely focus on security. Run load tests. Definitely run load tests against your application. K6 is pretty popular right now and works really well. Chaos kind of in two different ways. Run chaos against both the underlying platform, right? So go to pick a chaos platform to run on, and then be able to stress test Kubernetes. Stress test what happens when etcd and core DNS are under load, and how does your application perform there. But then also be able to run chaos in the application. Generally, if you're shipping your product to into a multi-tenant SaaS environment, you understand how your application is going to perform when a pod restarts or is not available, or it's doing a rolling update. It's really just the difference in the underlying platform, though, when Kubernetes is misbehaving, or it's something unexpected there. And just really focus on what happens when there's high load or partial outages in the platform, like slow disks or high packet loss, and the CNI providers not working as great as you want it to be. The thing too is really just we survey the customers. When you're gonna if you're gonna ship software behind the firewall, one of the things that we've built over years is really, it's a kind of a manual process, but it's just the first few customers you ship to, send them a survey where you're asking them everything from what OS are you going to run this on, what version of Kubernetes, what distribution, how do you update the Kubernetes, what CNI provider, what CSI provider, what container runtime are you running. And just understand all this, because there is this long tail, but there's absolutely a light at the end of the tunnel here, right? Each install is easier and easier and easier. So the first couple are going to be a little bit unknown for you, and go through those. But once you can definitely scale this and operationalize it, and just rely on those patterns over and over again, and rely on the tests. And then the last thing is really just bake all of the lessons that you learned. If you have a customer who has a problem running your software, go back and take the support archive that you have and enhance. If you had to do a one-off, can you grab the logs of this? Don't forget to go bake that back into the archive collection, so it's always in there, and then go write an analyzer rule for it, so the next customer doesn't have to go through that manual process, and continue to evolve and get the product more self-service. And you don't need to pull in the senior engineer in order to troubleshoot that cluster anymore.
Mm-hmm.
This all sounds very familiar to me in a way, right? And I may be oversimplifying, but I'm curious to get your take on this. Everything that you're talking about now, and some things that came up earlier about, all the differences between different Kubernetes rollouts and having to manage. Isn't this what Cloud Foundry was all about, of having an opinionated platform and making it so all you have to do is push your code? I mean, I guess the main problem with Cloud Foundry is you have this behemoth mass of servers that you need to run it on. But again, I may be being too simplistic here, but wasn't that the goal of Cloud Foundry, to do everything that we're trying to recreate through Kubernetes now by trying to get as many things standardized?
Yeah, I mean, I think it was. I think one of the I think one of the benefits of Kubernetes, though, is really it's vendor agnostic now, right? And if I want to run, Tanzu from VMware, and I have a contract with them, I can. But if I don't, and I just want a simple K3s cluster, I mean, obviously, depending on the expectations of that application, I might be able to do that. And all of the cloud providers have managed Kubernetes. It's just it's
right.
ubiquitous. Kubernetes is everywhere, and nothing's really been at that level yet until now.
Yeah, it just seems like everyone's trying to get to where Cloud Foundry was, but not through a vendor or massive hardware scaled component, which it's just always odd when you see someone come out with a good idea, but maybe again, I'm not saying Cloud Foundry is dead in any way, but obviously it didn't take off to the level that some people, I guess, hoped it would. It's just funny. I'm hearing all this and thinking sometimes people come along a little too early, I think.
Mark, how do you deal with scaling on-premise, meaning, right, if you run in SaaS, you obviously have your monitoring, you know how you can scale your resources with increasing demand. How do you deal with this, on the on-premise side? Do you just constantly, try to get some, monitoring data from the on-premise installation, and based on that, give new recommendations on how to scale, or how does this work?
Yeah. That's definitely an area that's like, there's a lot of variety, I think, today in how you ship to enterprise, because it's going to be dependent on the enterprise. It's like in a perfect world, you could rely on all of your customers to have, Kubernetes set up, with Prometheus and, both horizontal and vertical auto scaling groups, and everything is just going to handle that completely automatically. But realistically, that's just not always there. And some folks are running this as appliances, and they have, a 3-node cluster, and how do they handle that scale? And scale is also just interesting because, an enterprise customer, it may be that your largest enterprise customer starts to rival the size of your entire multi-tenant SaaS offering, or getting close to it. So like there can be like legitimately real scale there. And like it's going to be dependent on the applications. A lot of enterprise applications aren't going to have a very spiky workload where it's like, oh, it's Black Friday or holiday sales, and so now this like we need to scale this thing up 10x. It's predictable, it's linear scale and growth. So like definitely monitoring's key. Hook that in, like documentation of like how are you going to make sure you're really clear about the minimum requirements. A pattern that we've seen some companies do really well too is to say, like I think GitLab does this on their documentation, where they have a config for a 100 user, a config for a 1,000 user, and a config for a 10,000 user workload. And like they're different, but you just kind of pick that bucket that you want to go into, and just make sure you're like picking the right configuration, the right hardware to start with. Honestly, Andy, like one of the biggest challenges that we see in like when we troubleshoot and support these systems is just under provisioned, hardware, and just like it's crazy. Just put the right size hardware in there, and Kubernetes generally does a pretty good job.
Yeah. So what's funny is just this week we kind of in the process of shipping a new piece of software on premise as well, and we're just making these baby steps actually to deploy a new software on Kubernetes on the hardware of our customers. And one of the things we ran into this week, because I'm kind of leading the project, is exactly undersized hardware. We ran into file system issues. Not only, we ran into all sorts of interesting things we'd never thought of, right? So like, because we've been doing all sorts of testing, and in our environment, everything worked as expected. And then the first install, they had an old version of CentOS with a certain file system flag that was not turned on. Or then we had very strange network policies, or one environment was just a completely undersized environment because they were just saying, yeah, we just have a spare machine somewhere, you can use that. And right, that's, yeah.
And we've, recently, learned that this one, we were troubleshooting a customer on Azure recently, and Kubernetes, you have to have swap disabled on the operating system. When you're deploying Kubernetes, it doesn't work well if you have swap enabled. And so, we have a way to turn off swap, and you would expect that to be super consistent across every Linux flavor, every distribution, every kernel. And it is, except, this Azure ignores that and runs a script every time you reboot an instance that turns swap back on. And troubleshooting that, it's like that's this long tail that we talk about, right? Yeah. Where like there are these problems, they're unexpected. And I think, it's good news is it seems like there's an insurmountable number of these permutations that you're going to run into. But, in reality, there's not, right? There's not infinite cloud providers. There's not an infinite number of Kubernetes distributions out there. And they're not widespread, too. Like they're clustered together, and like a lot of your customers are going to like have the same configuration. So once you kind of figure out how to solve this, or we've been solving this for 5 or 6 years, and finding somebody who can help you solve this problem, to accelerate that a little bit. But it's pretty quick, and then like stuff just runs. Like Kubernetes it just solves this problem so well. And, as long as you know what you're getting into and you can manage it, like it stuff's going to be super reliable running in those customer environments.
Mm-hmm. Now, one more question that I have on, let's assume, well, you have a SaaS business, and then you have a handful number of managed customers, or with managed. I always say managed because in the Dynatrace world, Dynatrace managed means on-premise. So if you have a handful of people that run your software on-premise and that number grows, how do you keep track and how do you control and automate the rollout of the right version to all of your different remote on-premise customers? How do you do this, right? Because I would assume SaaS is always kind of the latest version that you have, and then you allow your on-premise customers to then say, do they also want to be on the latest, or maybe they want to be on a different update schedule? So my question is, first of all, is this the case, just the scenario that I explained, that most companies run the latest version in SaaS and then they roll it out to their on-premise customers, but maybe also with a slightly different schedule depending on the customer's need? And the second question is, if this is the case, you will end up with different versions of that software being distributed across the globe in SaaS and on-premise. How do you manage that? How do you manage version hell again, or how do you manage not version hell, because every installation is one version, but how do you keep an oversight of all of this?
Yeah, no, that's actually a great question. That is actually relatively common, right? Like you're probably doing continuous delivery to your SaaS environment. A lot of like what Replicated does is to help solve that problem. And I'm not going to like kind of dive into those details here, but like, at a high level, the way that we see the problem is really like, think about release channels, even among your current customers running the on-prem distribution, they're not all going to be on that same cadence. You may have large enterprises who say, we only want to update every 3 or 6 months. And you might have other customers, or even that large enterprise may have 2 installations of it, one where they're on the nightly or the weekly build. So we look at like, you should run continuous delivery into these customer into the on-prem product and make those available, but then have release channels. And you might just do something as simple as like nightly beta in like stable, but you can also have like a quarterly or like whatever release channels you want, and allow your customer to subscribe to those, and then they can get the updates that meet their requirements. Like large enterprises, especially regulated ones, are going to have like a process to ingest software, and they have to like, and it could be a little bit of a heavy process, and so they don't want to receive software every day from you. Like it's too time consuming for them, and so they want like more slow, like in reliable and stable and tested versions. But like I also do think like you can't allow that proliferation of versions just to go unchecked out there. Otherwise, your software is going to be super, super hard to support. And then your engineers are going to be thinking, great, we're building for Kubernetes 120, and we expect to be able to ship this new custom resource that depends on something that was introduced or doesn't depend on something that was deprecated. And you obviously don't want to be supporting customers running Kubernetes 113 today. And so we think about these like low water lines where you have to like really be able to have maybe you set a policy and you tell your customers you have to stay within 2 versions of our stable release channel, or 12 months, and that's a long time. But like like large enterprises do want these like LTS, long-term supported versions, and they want to keep them up and running for a while just for those reasons. But like yeah, you definitely have to think about both how you're going to update them and like when it's the customer's choice to update because they want the latest version, and when it's like a support, like you're out of the support window and we can't support that version anymore unless you do update.
Mm-hmm. And that makes a lot of sense. And I think it's also very aligned with what we are doing here on the Dynatrace side when we deploy our software to our on-premise customers. Now, I mean, we've built over the years our own, deployment models and deployment pipelines. So our team, fortunately, has been doing this for a while, and they've optimized this, so they know exactly what is deployed where. But for folks that you see out there, especially people that are starting, what type of tools would they use to really, get, keep an overview or really understand what is running where? Or is this something that you also have in your replicated solution?
Yeah. So for like non-air gapped installation, like the problem, I guess I would kind of divide into two problems. One is like internet connected installations, and one is like total air gapped installations. Mm-hmm. So for internet connected ones, yeah, like those are constantly checking for updates and syncing the license and stuff like this. And so we definitely do report back what version they're running. And so you can see, adoption rate of the latest version and drill into that. For air gap ones, we definitely take a lot of effort and put a lot of work into making sure that air gapped installations don't attempt to even reach out to the internet. Not like, you'll fail audits if you attempt to reach out, but like fail silently. Like a true air gapped environment just really can't even attempt to ping the internet, can't attempt to do a check. And so for those, you have to really rely on a couple of other options. One would just be, you can see when they've downloaded the latest version. There's no guarantees that means they've installed it or are successfully running it. You can collect one of those support archives, a support bundle, and in there report the version that's running and the status of it all. So, they redact all the sensitive information, and, you can, do a periodic review where they send that to you. And you're like, checking to make sure everything is running okay. And also you get a little bit of information about what version they're running. But, it's definitely one of the challenges of running software behind the firewall in total air gapped environments is you just there's no way that you can guarantee a lot of visibility into those.
Mm-hmm. Cool. Hey, Mark, this was extremely insightful for me. That I know we initially when we kind of set up this podcast recording, we wanted to primarily focus on performance, and I think we covered all this. But I think in general, this whole discussion about how we, as in our industry, deliver software that maybe runs in SaaS and now on premise, or maybe it starts on premise and then goes SaaS and then kind of lives in both worlds. All these considerations, all the things that can go wrong. I think you gave a lot of great insights for engineers, for people that architect these systems on what they should, what they need to understand, what can be different in these environments. Thankfully, at least that's what I hear, is Kubernetes definitely makes it easier to kind of expect a certain standard, yet there are still small nuances that might be different depending on the target OS, the target environment. Is there anything else in closing remarks that you want to make sure that the audience who's listening in that may contemplate right now, hey, our SaaS software would be great to run on premise too, because we have these and these sales opportunities? Anything else? Any links to literature? Anything we can pass on?
Yeah, no, for sure. I think, first thing is I know we talk a lot about the scary, hard problems to solve, but it's easier than it's ever been. Kubernetes makes it super easy. And I definitely don't want to scare anybody away. I just want to hey, there's no guarantee that just because your software works in Kubernetes on your laptop, that means you're going to ship it to an enterprise who's going to have success running it at scale, right? You have to be a little bit thoughtful about that. And that's what we do. I think, we're also, Andy, you and I talked a little while ago on the Kubeless podcast about Captain, and this whole world of building for SLIs, SLOs, and moving towards fully autonomous operations is super cool. And I think that's still, something we're starting to see a little bit in Kubernetes. And the more autonomous operations that you can package into your application, relying on, an Elasticsearch operator instead of manually running Elasticsearch. And now that operator can run that, just provides more reliability and more baked in, operational expertise into those. And so it's just going to work better and better and better. I think, it's easier than ever. And there are links, obviously Replicated as a platform, this is what we do, is what our team does every day. We've been doing it for 5.5 years, but there's open source projects, we use, we've created troubleshoot.sh, which is the, build your own support bundle, run it. You don't have to talk to us. It's just an open source project. Add analyzers, do all this we have there's shared Slack channels inside the Kubernetes Slack that for the troubleshoot project, and we're happy to talk. And honestly, like I'm always happy to chat about like shipping software on-prem, regardless of like how you're doing it, to understand the whole ecosystem better.
Very cool. Yeah, thank you so much for being on the show today. Brian, is there anything else from your end that you wanted to add?
No, nothing on my end. It was all very, very interesting. And it's if you think back to the earlier conversations we had about Kubernetes, Andy, a couple of years ago, it's crazy how far it's come and how much it's dominated. Just mind blowing.
Yeah.
So this is a very interesting conversation just to be listening to, because it's so far from where we were. Well, thanks everyone for listening. Mark, thanks again for joining us. It's been really great having you on. If anybody has any questions or comments, you can reach us at pure_DT at Twitter, or you can send an email at pureperformance@dynatrace.com. Mark, where can people go to find out more about you and everything related to the wonderful goodness of Replicated?
Yeah, so I mean, we're at replicated.com, or we have our k8s product, which is, we didn't talk about that by name, but this is Kubernetes off the shelf, and it's at k8s.io, k8s.io.
Awesome. Okay, we'll put some of those links out in the show notes as well. Thank you everyone for listening, and we'll see you next episode. Bye-bye.
Bye-bye.